This is actually the last lesson from this chapter. And then there's basically Friday, Monday, and Tuesday we got kind of just a bigger review to do, which is fine. Okay? So I think one thing that you've started to catch on in statistics is a lot of times in statistics you can kind of manipulate a few things. So when we're using the chi-squared, for multivariables, which is basically the diagrams that we've been using, like up on the board. So in order for normalcy to take place, the big one is you're looking for, do we have random? The other one is the expected values of all 5 or greater. Okay? So that's the first thing I want to talk about. So have you started realizing that in statistics we want to make things work for us, especially if we've done a lot of time and effort into things? So when we are doing chi-squared and we're looking at the degrees of freedom on the chart, when you're doing degrees of freedom, it is the row minus 1 times the column minus 1. And what this is basically doing is this is allowing error to take place. Okay? Means you're accommodating any slight deficiencies in it. So if we went back through and did this whole thing with the Atlantic, Pacific, and Indian Oceans with categories 1, 2, 3, 4, and 5, if you did your expected values, some of those expected values for, I'd say probably category 5, and then category 4 in the Indian, probably category 3 in the Indian, maybe even category 2 in the Indian Ocean, the expected values of each of those will be less than 5. Okay? So how can you make it work? How can you make it work to make it basically show that there is there's the appropriate distribution? And what you can start doing is you can start collapsing your variables a little bit. Okay, bless you. So what that basically means is, being that there's not quite as many category 4 and category 5 hurricanes taking place, they might collapse category 4 and 5 and make it their one thing. They might, just find a seat. They might make it, collapse it down, and when you collapse it down, that allows the new expected value to take place. But if I collapse down my stuff, my degrees of freedom changes. So as of right now, the Atlantic, Pacific, Indian Oceans with category 1, 2, 3, 4, 5, you have 15 items that are within your grid. So your degrees of freedom would be 5 minus 1, 3 minus 1. So 5 minus 1 is 4, 3 minus 1 is 2. If I multiply those together, I get 8. Okay? So I want you to see that how Desmos will accommodate this type of thing, and this is how the chi-squared recognizes that you might have a little bit of error that takes place. So if I were to take that down and I did a chi-squared distribution on it, so chi-squared distribution. If I did a chi-squared distribution, what we have up there, we said it was 4 times 2, so it was 8. Okay? So this is the chi-squared distribution that's taking place with what we're looking at up there. Now, if I collapse category 4 and 5 to become its own category, that means I no longer have 4 categories going across the top. I only have 4 of them. So then my degrees of freedom is going to change. So that becomes basically you have 4 categories on top, still 3 with the different oceans on the left side. So if you did the chi-square distribution based on this, and I'll just do it on the next line, an interesting thing to kind of ponder, as interesting as chi-square could be, if I have a 4 by 3, so degrees of freedom would be 4 minus 1, which is 3, and then 3 minus 1, which is 2, so 3 times 2. So then I drop down to degrees of freedom of 6 degrees of freedom. So notice the blue versus the red. Okay, there are different things that are taking place in each of these. And because this is pulling, the blue is pulling back towards the y-axis, becoming a taller situation. That means that things that are here are happening less often. You know, as I go to the right, things are happening less often, and that's where, and you know, if you're negotiating for the error by collapsing a thing down, and when you collapse it down, that again takes that expected value and it changes that expected value to be 5 or greater, which that's what you want when you're dealing with statistics. It's acceptable to do. It's don't hide that you did it. I mean, you can easily say that you know, if you went and you talked about, say, ice cream flavors, you know, what's your favorite ice cream flavor at a local place, you know, not including the mix-ins. You know, you might say, you know, chocolate and vanilla are my top ones, and then you might have another category of other, because, like, you know, did you guys ever go to Baskin Robbins, which was known as 31 flavors at the time? It's called 31 flavors because they supposedly had 31 different flavors of ice cream. Yes. So 31 flavors definitely didn't have the amount of, oh, I don't know, pistachio ice cream sold as they would as chocolate or vanilla or Rocky Road or something like that. So what that company might have done is, if they were trying to gauge, you know, let's say you were picking, let's say on the left side rather than Atlantic, Pacific, and Indian, perhaps you said summer, fall, winter, spring, and then you created all your categories where it's like, you know, well, the top one's chocolate. You know, I'm just speculating. I don't know that for sure. But as you go through the ice cream flavors, there's definitely some that if you were walking through that little aisle and a person's scooping, you're like, that ice cream might not be good because there's not even a scoop taken out of it, versus, oh my gosh, my first favorite flavor, they're, you know, chocolate fudge brownie Reese's peanut butter cups and 12 other items in there, that's almost gone. Okay, so you can kind of see just by you doing a visual inspection of an ice cream place, you could actually see which ice cream might be the most favored, but you don't know if that might be, you know, they might have, some of the ones that are full, though, they might have actually put a new ice cream in that place because the last one got, you know, emptied. But you're collapsing your information. So if you talk about like a cumulative chi-squared, and I don't know, let's say we said this was, oops, that's 6. Let's change that to 6 to infinity. Oops. And then do the same thing here. Let's go 6 to infinity. Okay, so you notice something that takes place, and I just arbitrarily use the number 6, and that number 6 would have been gotten by us summing up all of our chi-square distribution. We added up. So once we went through and did all the expected values that we found the chi-squared by doing the observed by the expected, quantity squared divided by the expected, and summed all those up, let's say it came out to 6. Well, you notice your p-value changes when you had the larger distribution, which basically means, yeah, we're on the same location here, which is the number 6 on the x-axis, but the area we are talking about to the right becomes a smaller area as you reduce your degrees of freedom, which then accounts for, yeah, there might have been some error. In order to make our chi-square distribution work, we could combine some of our columns or even some of our rows, and that would have allowed those to have the higher expected value. And as long as it said, hey, this is a normal, this is randomly selected, which this particular thing, I believe when we first looked at it, did say it was a random look at all the hurricanes. But if it talks about being random, that's a big check mark saying this is good. If your chi-squared value is less than 5, or your expected value is less than 5 on any one of your categories, that's a red flag. But if you combine your information, okay, so some people might actually call this, you are massaging the data. You're massaging the data to fall into saying, yeah, we're using a chi-square distribution by us collapsing these. All of our expected values are 5 and above. That's great. So it is acceptable, and it is acceptable in the statistics community to do that. It also, cuts down on a whole lot more work if you break down those chi-square distributions. So it says at the top, the chi-square test for homogeneity is mathematical identical to chi-square test for independence. The difference is in the way we look at the data. Consider the following hurricane data set used in the previous assignment. So we've done this. It says on the second hand, we could look at the data if we're testing the relationship between ocean and hurricane intensity, and the variables are independent of each other. This creates a test of independence. So on the other hand, we could look at the 3 different hurricane distributions across the 3 oceans. Do the oceans possess the same distribution of hurricanes percentage-wise? This creates a test of homogeneity of variance. Okay, so variance is another nice way of saying error. Okay, the only alternative hypothesis for homogeneity variance test looks like are null. The 3 oceans possess the same distribution of hurricane intensities. An alternative, the 3 oceans possess different distributions of hurricane intensities. Okay, so I did this in one of my other classes. It was my business calc class. We actually came across, you ever come across a word problem that just doesn't make sense?
Oh, yeah.
You've read it like 12 times and you're like, what is this asking? You've run across this error before? Me too. And I actually had a problem in my business calc class that, I read it and I kind of, just by, playing a little dumb on it, I was able to get probably about half the class to say, I think it says this, and the other half of the class said this. And it's like, well, what's the right way to think about it? So let me give you an option. Yeah. Let me give you an option that really might help you. It's called ChatGPT. Okay. Yeah, it's this new thing just came out yesterday. So there's a sentence up there that, or a paragraph that I'm a little bit concerned about and what it really says. Okay. So I'm going to say this, that can you reword this paragraph into an easier language? And I'm going to say that, let's see, we could look at it as 3 different hurricane, through 2 hours in hurricane. I can't read that. It's too far away. Watch your toes. Thanks. I have to move closer because I can't see that far. These trifocals just aren't working as well as they had yesterday. All right, so where was I at? We could look at these 3 different hurricane distributions across the 3 oceans, Indian, Pacific, and Atlantic. Do the three oceans possess the same distribution of hurricanes? This creates a test of homogeneity of variance. Spell things correctly, I'd be a much better typer. All right, so the thing is, I don't necessarily understand the wording of it. So if I put this up there, and you guys all know, seen how this works. All right, I kind of like this. So I put in the original words, and it says we can think of it as 3 different groups of hurricanes in the Indian, Pacific, and Atlantic Oceans. Do these oceans have the same pattern of hurricanes? This question helps us check if the hurricane patterns are similar or different. Okay? I feel the 2 saying the same thing, but this right here, this creates a test of homogeneity of variance. So we'll do, sir, what does that mean? This question helps us to check to see if the hurricane patterns are similar or different. That's easier language. But we all know that AI is here to stay, right? And it's just going to continue to build upon itself more and more and more. How do you choose to use it depends on what you want to do. I mean, if you're using it to write your papers, well, I don't know if that's always going to be the best model because it's not given clairvoyant thought to it, but it's just something to think about. And like, could you imagine? You remember those math tests back in prior to statistics? You got the word problem, and that was the easiest problem for the teacher to ever grade because 2/3 of the kids left it blank. Remember that in Algebra 1? You had one word problem. The rest were like, hey, find the slope of this line, this. And it's like, Billy takes 12, he wants to get on a skateboard and ride to school, and it takes him 10 minutes to ride to school, and you're like, I don't even, and we as teachers, we try and create a simpler way of I'm going to engage kids. I'm going to talk about skateboarding. Kids are going to love that. And then you get half the kids that hate skateboarding. So, the teacher missed their mark. I mean, could you imagine if you could, if you had the opportunity, type in a question, not asking it to solve it, but it's like, can you reword this into simpler terms? I think that might be helpful. Heck, that might have helped a whole heck of a lot of students in previous classes. So what I encourage you to do, and I know many of you are going to the next level of college, and that's great. If you're not choosing to go to college, that's also great. But no matter what field you're in, think about how you might utilize AI to help you with something. We've all read directions on how to do something, and a lot of times you read directions, you're like, what does that say? Well, this might be an option for you to say, oh, wait a minute. This does make more sense. So just something to kind of think about. You know, I'm not saying that you should or shouldn't use, AI. I think it's another valuable tool. And I think the thought processes of people, you guys, you're going to be able to conquer and deal with problems that we have today in your future that, because of AI, might simplify it for you and then allow you to think even further ahead of what something would have been. Okay? Don't you guys get sick and tired of hearing, oh, your generation's this or that? I grew up hearing my grandparents, oh, your generation has no idea. No idea. You want to know what me as a generation did as a sample set of one that's not randomly selected? If I look at my grandparents on both sides and my parents, and even my wife's parents, my father-in-law retired at 50 years old. He did very well with business and investments and was able to retire. I think he did a little bit better than I am doing, though I could have retired. Okay, I don't want to retire. Okay, I don't really feel like I work a whole lot. It's like, you're here all the time. I know, it's not work though. When I look at where my mother and father, and my mother passed away 2 years ago, when I first had a look at what they had, first thing I asked my dad is like, how in the heck are you guys retired? Because there wasn't money. There wasn't the kind of money that, Dad had Cadillac Dreams on a Ford Pinto's budget, and overspent and overextended his credit. We were fortunate that Mom had a $100,000 life insurance policy. So between my wife and I, we told my dad, we're going to get you out of debt, and this is how we're going to do it. And we had to put my dad on a budget, and we got him out of debt within 4 months. And then, gladly, because he's not spending like he had, and he's getting his Social Security and my mom's retirement and his veterans retirement, I was able, within the last 2.5 years, triple what my dad had in retirement, using his retirement to build upon it. So it's just kind of thing. So when people say, oh, you generation, you don't have this or that, oh my gosh, no, you as a generation, you've gained all of the problems that my generation has had, but now you have something that's going to allow you to work with you and help you. And I think you guys are in a much better position than I was. So when you guys hit the rightful age of 54, you can have the kind of money saved that I have saved right now, and beyond that, I did my job. All right, so null and alternative we talked about. It says we reject the null hypothesis to find strong evidence that the three oceans possess different distributions of hurricane intensities. If we fail to reject the null hypothesis, we fail to find strong evidence that the three oceans possess different distributions of hurricane intensities. Otherwise, the mathematical degrees of freedom, assumptions, and methods for calculating the p-value are the same. We noted the assumptions are not passed for this particular chi-squared test. Indeed, many of the expected values are below 5, which we talked about. This is a significant problem. It undermines the trust in the results of our hypothesis test. However, techniques often referred to as collapsing categories can be used to rebuild the contingency table so that the assumptions are passed. This idea is simple. Rather than using all 5 categories of hurricanes, we combine the more rare categories. So a collapsed contingency table for hurricanes data is shown on the next page. So we're going from this to this. So it looks like they collapsed 4 and 5 and combined them into category 3. So now you go category 1, category 2, categories 3, 4, and 5. And this changes our degrees of freedom significantly. Heck, I had done it one way. The degrees of freedom of this is 3 minus 1, 3 minus 1. So my degrees of freedom of this one, from going from 8 degrees of freedom Now I'm even going to change it to 4 degrees. And if I change this to 4 degrees, this is going to really change things. Look how small my p-value is now with 4 degrees of freedom. I go from the original of 0.647 to 0.199. Now, it's still above 0.05, but we are finding more and more evidence based on that situation. So it's, again, a way of saying you're massaging the data, but it's totally acceptable to do, which is kind of a cool thing. Okay, if it satisfies the world of statistics, then it's got to be good for what we're trying to conclude. Says this might seem to undermine the data, and actually collapsing variables does lose a level of precision. Okay, our level of precision we're losing is because this little area here, this blue area here, is far smaller than the red area that's on the board. Degrees of freedom of 8 had a much bigger area. In fact, it was 64.7% of the area, whereas in this case, we're talking about 19.9% of the area. Okay? However, the chi-squared test inherently involves categories of variables, which gives us a lot of choice about how to construct the categories. In this diagram, all expected values are larger than 5. So let's just run through the expected values. Now, we had the expected values a long time ago on this, so I'm not going to do the original. But I need to grab a calculator to do this. We first have to remember the expected value equation. So let me collapse this down, being we're collapsing data. The expected value is the row total times the column total over the total. Okay, so if I have my Atlantic, Pacific, Indian categories 1, 2, and 3, 4, 5. So 2016-17. Where over here on the right is still the same because we're still talking about the same number of storms. (10.44). And down here is 46, 38, 36, and 110. So expected value, row total. So for A1, we have 53 times 46 divided by 110. And this is still going to be the same number it had been. So this is 22.2. And then if I go across, then I'm going to go 53 times 38 divided by 110. And this still would have been the same of what we had. So 18.3. And where it's going to change is in the last category for the 3, 4, 5, 53 times 36 divided by 110. So now it's up to 17.3, and it would continue as you go through and do the rest of it. If I did all the rest of these, so I only did right across the board here, and it's clearly starting to show. If I went to look at this one right here, which you're saying it's kind of low, the expected value there is going to be 18 times 38 divided by 110. So that comes out to now 6.2. Whereas somewhere in the 4th or 5th hurricane category, that would not have been 6.2. It would have been less than 5, which kind of goes against it. So that's all I have to speak to you guys about for now, if that's okay. You take a look at the assignment that comes. But I'll ask you this. If you So that's on page 137, 138. Take a look at it. And this is talking about restaurants and ages of people. So that's what it goes with. So I don't know if it's going to ask you to collapse any of the columns. Maybe you do, I don't know. So you can easily go through and do some of that, get a look at it. We'll go over that tomorrow. Start our review tomorrow, continue our review on Monday, continue our review on Tuesday, Wednesday. Even though we have advisory, we might have the opportunity to do that test on Wednesday next week. Cool?